Chapter 9, Directives and Pipes. This chapter defines and explores custom and built-in directives, differentiating structural versus attribute directives. You'll also learn about built-in pipes like date, currency, and async, and how to create custom pipes to format or transform data in templates. In Angular, directives and pipes are two powerful concepts that enhance how developers build dynamic, flexible, and reusable user interfaces. Directives in Angular are classes that add behavior to elements in the Angular application. They allow developers to manipulate the document object model, modify the appearance or behavior of DOM elements, and react to user events. Angular provides three types of directives: components, which are actually directives with templates; structural directives, which change the layout of the DOM by adding or removing elements; and attribute directives, which change the appearance or behavior of an element, component, or another directive. Structural directives are easily recognizable because they typically use an asterisk symbol. A classic example is the ngIf directive, which conditionally includes or excludes an element in the layout depending on a Boolean value. Another example is ing_for, which repeats a portion of the DOM tree for each item in a list. Attribute directives, on the other hand, are used to modify the appearance or behavior of an element without altering its structure. Examples include ing_class and ing_style, which allow dynamic modification of classes and styles respectively. Developers can also create custom attribute and structural directives by using the directive decorator and handling the desired logic in the directives class. Pipes in Angular are a simple way to transform displayed data in templates. They take in data as input and return a transformed version of that data as output. Pipes are useful for displaying dates, currency, percentages, text formatting, and many other types of data transformations directly inside the HTML template. Built-in pipes, such as date pipe, currency pipe, and uppercase pipe, make it easy to format common data types without cluttering the component logic. Custom pipes can also be created to handle specific transformation requirements. Creating a custom pipe involves implementing the pipe transform interface and defining the logic inside the transform method. Angular's change detection system works closely with pipes to ensure that data transformations stay updated with minimal overhead. Pure pipes, which are pipes that depend solely on their inputs, are only recalculated when the input reference changes. Impure pipes, on the other hand, are recalculated on every change detection cycle and should be used sparingly for performance reasons. Both directives and pipes are fundamental to writing clean, declarative Angular templates. Directives control how elements behave, while pipes control how data is displayed. Together, they enable developers to create powerful, efficient, and scalable Angular applications. Chapter 10, Component Interaction and State Sharing, focuses on parent-child component communication using input and output decorators, event emitters, shared services for cross-component communication, and techniques like viewChild and ContentChild. Also introduces the concept of a shared state and how to manage it in small to medium applications. Here's a clean, technical audiobook-style text on component interaction and state sharing in Angular, without bullets or lists. In Angular applications, component interaction and state sharing are essential for building cohesive and maintainable systems. Components in Angular are isolated by design, each with its own view and logic. However, in real-world applications, components often need to communicate, share data, and coordinate actions. There are several core techniques for component interaction in Angular. One common approach is through the use of input and output decorators. The input decorator allows a parent component to pass data down into a child component. This is a unidirectional flow, ensuring that the child only receives data without modifying the parent's internal state. Conversely, the output decorator enables a child component to emit events back up to its parent. By using an event emitter, a child component can signal to its parent that a user action or other event has occurred, and the parent can respond appropriately. Another important technique involves viewChild and ContentChild decorators. ViewChild allows a parent component to directly access the properties and methods of a child component after it has been rendered. This is especially useful when a parent needs to call a child's method or read its internal state dynamically. ContentChild is used in cases where content is projected into a component using Angular's ing_content directive, allowing access to child elements or components that were provided by a parent through content projection. For more complex applications where state needs to be shared across many components, Angular developers often rely on shared services. A service in Angular is a singleton instance, which means that once it is created, it is reused wherever it is injected. By using a shared service, components that are otherwise unrelated in the hierarchy can subscribe to the same data streams, invoke shared methods, and react to changes centrally. Services often use observables, provided by the RxJS library, to maintain reactive and event-driven data sharing. Observables allow multiple subscribers to listen to changes and react asynchronously whenever new data is emitted. State management becomes even more critical as applications grow. For larger and more complex state handling, developers might use a more formal state management pattern such as Redux-inspired ING-RX. ING-RX provides a structured and predictable way to manage global application state through actions, reducers, and stores, ensuring that all components interact with a single source of truth. Component interaction and state sharing are at the heart of any successful Angular application. Choosing the right interaction strategy, whether it is simple property binding, event emitting, shared services, or full-blown state management, is crucial for maintaining performance, scalability, and readability of the codebase. Mastery of these patterns leads to applications that are not only more modular but also easier to extend, debug, and maintain over time. Chapter 11, Angular CLI and Development Workflow, covers the Angular CLI as the command line interface tool for creating, building, testing, and serving Angular apps. This chapter introduces the CLI workspace, project schematics, file generation, linting, and optimization flags for production builds. The Angular command line interface, commonly known as the Angular CLI, is a powerful tool that significantly enhances the developer experience when building Angular applications. It is designed to automate and streamline many common tasks in the development workflow, allowing developers to focus more on writing business logic and less on project configuration and setup. At its core, the Angular CLI provides commands to create a new Angular project with all necessary dependencies and a standardized folder structure. With a single command, developers can generate a fully working application scaffold that adheres to Angular's best practices. Beyond project creation, the CLI is extensively used for generating application features such as components, services, pipes, modules, and directives. Each generated artifact comes pre-wired with boilerplate code, proper imports, and ready-to-use integration points, ensuring consistency and reducing manual errors. During active development, the CLI offers a built-in development server that allows real-time application testing. Running the server starts a live reloading environment, where any change in code instantly reflects in the browser without the need for manual refreshing. This tight feedback loop greatly accelerates the pace of development. The CLI also handles the compilation of TypeScript into JavaScript, manages source maps for easier debugging, and optimizes performance with ahead-of-time (AOT) compilation when needed. Testing is another area where the Angular CLI plays a crucial role. It sets up unit testing with Karma and Jasmine by default, and allows developers to run test suites with a simple command. End-to-end testing is equally supported, with Protractor being the default framework, although alternatives like Cypress can also be integrated. The CLI manages configurations for different environments such as development, staging, and production, enabling developers to switch between them smoothly without duplicating codebases. When it comes time to build the application for production, the Angular CLI optimizes the output by minimizing bundles, removing unused code through tree shaking, and applying ahead-of-time compilation for faster load times. It produces a highly efficient, deployable set of static assets that can be hosted on any web server or integrated into a more complex back-end system. Throughout the entire development workflow, from project creation to final deployment, the Angular CLI enforces a high level of structure, consistency, and automation. This reduces the cognitive load on developers, improves team collaboration by maintaining uniform coding standards, and significantly shortens the time from idea to delivery. Mastery of the Angular CLI is essential for modern Angular development, as it unlocks the full productivity potential of the framework and ensures that applications are built with reliability, efficiency, and scalability in mind. Chapter 12, Testing in Angular, explains Angular's approach to unit testing and end-to-end testing. You'll hear about the test bed utility, Jasmine testing framework, mocking dependencies, spying on services, testing components, pipes, directives, and making your application more testable. It also touches on E2E testing tools like Cypress and Playwright as alternatives to Protractor. Testing in Angular is a first-class citizen, deeply integrated into the framework's philosophy to ensure applications are robust, reliable, and maintainable. From the outset, Angular projects are scaffolded with testing frameworks already configured, providing a smooth entry point for developers to build and maintain a strong testing culture. Unit testing in Angular focuses on validating individual components, services, pipes, and directives in isolation. The Angular CLI sets up Karma as the default test runner and Jasmine as the testing framework, although alternatives can be integrated if necessary. Unit tests ensure that small pieces of the application work as expected independently, without external dependencies. Components are tested by creating instances using Angular's testbed utility. which simulates Angular's dependency injection system in a testing environment. This makes it easy to mock services, simulate user interactions, and verify component behavior through assertions. Beyond unit testing, Angular also supports end-to-end testing to simulate real user scenarios. Protractor, an end-to-end testing framework built specifically for Angular applications, allows developers to script browser-based tests that interact with the UI just as a real user would. These tests help catch issues that may arise from component integration, routing, or asynchronous behavior. Although Protractor has historically been the default tool, many teams now prefer to integrate Cypress for its more modern feature set and easier debugging experience. A key aspect of Angular testing is the use of mocks and spies. Services, APIs, and event handlers are often mocked to isolate the component under test and avoid external dependencies. Jasmine provides spy utilities that can verify whether methods are called, how many times they are called, and with what arguments. This makes it possible to write very granular and precise unit tests that only focus on the logic being validated. Testing in Angular also emphasizes the importance of coverage. Code coverage tools automatically report how much of the code base is exercised by the test suite. This provides visibility into potential gaps where untested logic may hide, helping teams maintain a healthy, reliable codebase as it grows. For more sophisticated testing strategies, Angular supports dependency injection tokens that can be replaced with test doubles during unit tests, and environments can be configured to run different sets of tests depending on the build target. The framework's design encourages writing pure, predictable functions and separating concerns, which naturally leads to easier, faster, and more maintainable tests. Ultimately, testing in Angular is not an afterthought but a core part of the development process. It enables developers to build complex applications with confidence, refactor safely, and ensure that changes do not introduce unintended regressions. By leveraging Angular's comprehensive testing support, developers can deliver higher quality applications that scale gracefully and endure over time. Chapter 13. Change Detection and Performance Optimization. Dive into Angular's change detection strategy and the use of zones. It explains how on-push change detection can dramatically improve performance and when to use it. This chapter also introduces techniques such as lazy loading, ahead-of-time compilation, tree shaking, and track-by functions to optimize runtime efficiency. Here's a technical audiobook-style narrative for change detection and performance optimization in Angular, without bullets or lists, written smoothly and professionally. Change detection is a fundamental mechanism in Angular that ensures the application state and the user interface stay in sync. Every time an event occurs, such as user input, an HTTP response, or a timer triggering, Angular's change detection system runs to check if the underlying data model has changed. If a change is detected, Angular updates the view to reflect the latest state of the application. This process is crucial for keeping applications reactive and dynamic. Angular's default change detection strategy is very efficient for most applications, using a mechanism called the Zone.js library. Zone.js patches asynchronous operations like set timeout, HTTP requests, and user events, so that Angular knows exactly when to run change detection. However, in large or highly dynamic applications, running change detection too frequently can cause performance bottlenecks. Each change detection cycle re-evaluates bindings for all components in the application tree, even if only a small part of the data actually changed. To optimize performance, Angular offers two main strategies. The first is the on-push change detection strategy. When a component is configured with on-push, Angular only checks it for changes when one of its input properties changes, or when an event originates from within the component itself. This drastically reduces the number of times Angular needs to traverse and update the component tree. Using on-push encourages developers to write more predictable, immutable code because Angular relies on input object references to detect changes rather than deep comparisons. Another key optimization technique involves detaching and manually triggering change detection in performance-critical parts of the application. Developers can use the Change Detector ref service to control when a specific component should be checked for changes, providing granular control over performance-sensitive scenarios. This technique is especially useful in highly interactive dashboards, animation-heavy UIs, or large data tables where uncontrolled frequent updates can degrade the user experience. Lazy loading is another important aspect of performance optimization in Angular applications. By splitting the application into modules and loading them only when needed, developers can drastically reduce the initial load time, improving perceived performance. Similarly, the use of track-by functions in structural directives like ing prevents unnecessary DOM manipulation by informing Angular how to uniquely identify items in a list. Optimizing performance also extends beyond change detection to areas such as efficient API usage, minimizing DOAM manipulations, preloading strategies for modules, and using lightweight libraries. Ahead-of-time compilation reduces runtime template parsing overhead, while service workers and caching mechanisms improve offline experience and reduce server load. In the end, mastering change detection and performance optimization in Angular is crucial for delivering fast, responsive, and scalable applications. Developers must understand when Angular runs change detection and learn how to control it intelligently to balance application responsiveness with resource efficiency. Well-optimized Angular applications not only provide better user experiences but also scale more effectively under heavy usage and complex feature sets. Chapter 14, Angular Material and UI Component Libraries, provides an overview of Angular Material, a component library based on Google's Material Design. You'll learn how to build responsive layouts, use pre-built UI components like form fields, buttons, and data tables, and how to theme your application. Here's a technical audiobook-style text for Angular Material and UI Component Libraries, without bullets or lists, natural and professional. Angular Material is the official UI component library developed by the Angular team, designed to provide a high-quality, consistent, and accessible set of components that follow the material design guidelines. It integrates tightly with Angular's core framework and serves as a comprehensive toolkit for building modern, responsive, and maintainable user interfaces. Angular Material offers a wide range of ready-to-use UI components such as buttons, form controls, navigation elements, data tables, and dialogues. Each component is engineered for usability, performance, and adaptability across devices. These components come with built-in support for themes, allowing developers to easily apply consistent styling across an entire application by switching color palettes or typography settings globally. Angular Material also emphasizes accessibility from the ground up, ensuring that applications built with it meet WCAG standards and provide an inclusive experience for all users. Using Angular Material significantly speeds up front-end development. Instead of building custom buttons, input fields, or navigation menus from scratch, developers can use these pre-built, well-tested components and customize them through configuration and theming. Angular Material components are also optimized for performance, minimizing the need for developers to handle low-level DOM interactions or worry about cross-browser compatibility issues. Beyond Angular Material, the Angular ecosystem supports several other UI component libraries that cater to different design languages and development needs. Libraries like PrimeNG, NGZoro, and Nebular offer rich sets of components styled according to various themes and branding guidelines. PrimeNG focuses on flexibility and provides hundreds of components, while NGZoro is a library based on Ant design, popular in enterprise applications. Nebular, on the other hand, offers a customizable theme engine alongside UI components tailored for admin dashboards and complex applications. Integrating a UI library into an Angular application typically involves installing the library package, importing individual modules into the Angular app module or feature modules, and optionally customizing global themes. Proper use of Angular's lazy loading and tree shaking ensures that only the components actually used in the application are included in the final build, keeping the application lightweight. Choosing the right UI component library depends on several factors, including the design requirements of the project, the complexity of the components needed, community support, and how tightly the library aligns with Angular's reactive forms and change detection model. Angular Material is often preferred for applications aiming for a clean, professional, and consistent material design look, while alternatives might be selected for projects needing broader customization or different design systems. In all cases, UI component libraries are essential for accelerating development, ensuring consistent user experiences, and reducing the time and effort required to create complex, interactive web applications. Mastery of Angular Material and familiarity with the broader ecosystem of UI libraries empowers developers to deliver rich, dynamic user interfaces with confidence and efficiency. Chapter 15, Angular Universal and Server-Side Rendering, explains what Angular Universal is and how it helps improve SEO and initial load time by rendering Angular applications on the server. The chapter guides you through setting up Angular Universal, rendering pages on the server, and optimizing the user experience with pre-rendering. Angular Universal is the technology that enables server-side rendering for Angular applications. In a standard Angular application, rendering occurs entirely on the client side, meaning that the browser downloads the JavaScript, executes it, and dynamically builds the user interface. While this approach is highly interactive, it introduces challenges for initial page load times and search engine optimization, especially for users with slow network connections or devices with limited processing power. Server-side rendering with Angular Universal addresses these challenges by generating the HTML content of the application on the server before it is sent to the browser. When a user requests a page, the server pre-renders the application into fully populated HTML and delivers it to the client. As a result, users see a fully loaded page much faster, improving the perceived performance and making the application more accessible to search engines that rely on server-rendered content for indexing. The core concept behind Angular Universal involves creating a server-side version of the Angular application that runs on a Node.js server. This server-side application bootstraps the Angular app, renders the requested page based on the route, and returns the static HTML to the browser. Once the browser receives the server-rendered page, Angular seamlessly takes over through a process called hydration, allowing the client-side application to become fully interactive without having to reload or re-render the page from scratch. Setting up Angular Universal typically involves using the Angular CLI to add server-side rendering capabilities to an existing Angular project. The CLI command generates a server-side application module and configuration files, including a Node.js Express server to handle HTTP requests. Developers can customize the server logic to manage caching, API calls, and route handling as needed. During the build process, Angular compiles both the client-side and server-side applications, creating a unified deployment package. Using server-side rendering also brings challenges, particularly around managing state and asynchronous operations. Since server-side rendering happens outside the browser, developers must be careful with code that relies on browser-specific APIs such as window or document. Angular Universal provides abstractions and utilities to handle such cases gracefully, but it requires careful attention to avoid runtime errors during server rendering. Performance optimization is a critical part of server-side rendering. Techniques such as lazy loading modules, caching rendered pages, and reducing the size of server responses play significant roles in ensuring that the benefits of server-side rendering are fully realized without introducing bottlenecks. For applications with dynamic content, strategies like pre-rendering frequently accessed routes and using incremental static regeneration can further enhance performance and scalability. Angular Universal fundamentally changes how Angular applications are delivered to users. By providing fast, server-rendered HTML combined with rich client-side interactivity, it enables Angular apps to offer the best of both worlds, excellent user experiences and improved search engine visibility. Mastering Angular Universal and server-side rendering strategies is essential for developers building high-performance, large-scale Angular applications that need to be competitive in modern web environments.